They have similar symbols, but they are completely different. It's not just the direction of the arrows that's different. They might look alike, but their operating methods are completely different. In this video, we will learn about the difference between LEDs and photodiodes. This is an LED. It's one of the most common components you see in circuits. Basically, an LED acts as a diode that sends current in one direction while visually emitting light. Looking at the symbol, it's a diode symbol with arrows pointing outward. This means it emits light while performing the diode function. However, since it includes the diode function, you can just connect it any way you like. If you look at the component, there is a short leg and long leg. The long leg is plus, the anode. The short leg is minus, the cathode. The general circuit connection method is like this. So, how is the light created? This lies in the diode's PN junction. For a detailed video on diodes, please refer to the recommended video at the top. When power is applied, the plus of the P-type silicon and minus of the N-type silicon meet. At this time, we can say the energy intensity of the plus is stronger. For example, let's assume the power is applied and plus and minus met. Let's say the energy intensity of plus is 3 and minus is 1. For these two to combine, plus needs to discard 2 units of energy. This discarded 2 units of energy is thrown outwards and becomes light. Also, when using an LED, we almost always use a resistor with it. This is because of the LED's fault current. The appropriate current for a general small LED is 20 mA. If excessive current flows beyond this, the LED will burn out. We will cover the process of how LED colors are determined in detail in the next video. Please subscribe to the channel. The symbol looks like the LED's arrow are reserved. If the LED's arrow direction means emitting light, the photodiode means absorbing light. The light mentioned here is not the wavelength of standard LED light, but usually the wavelength of infrared light. It operates by absorbing light emitted from an infrared LED. The biggest difference from an LED is in the connection method. Here is the general LED circuit connection method I showed earlier. The anode is at the plus side, the cathode is at the minus side, and resistor is attached either before or after the LED. However, the photodiode is connected in reverse bias. The cathode is connected to the plus side, and the anode is connected to the minus side. This method normally blocks the current, but opens the gate to allow current to flow only at the moment a specific light hits it. The terms used here are dark current and light current. Dark current refers to the minute current that flows when the photodiode is not operating. Although very minute, this can cause noise in the entire circuit. Light current is the amount of current that can flow when light shines on the photodiode while it is operating. The reason the outer casing is black is to block general visible light and allow all infrared light to enter. In this video, we briefly learned about the principles of LEDs and photodiodes. Next time, we will look at how LED colors are determined and the photocoupler's principle. If this video was helpful, please subscribe and like button. Thank you for watching.